things what I have discussed with you. Okay. And these are basically the conversions of energy from one form to another form. And that energy is basically converted from kinetic to potential and potential to kinetic, etc. etc. Okay. Now, as I told you, last thing what I wanted to add here in this entire discussion for the last notes, I have added. Yeah, these all are the same calculations. No worries at all, right? So don't get worried. Sir, these are some new points. So I just want to you know, one shortest description about what all we have studied in previous 2 days. If you have the if you want to calculate the work done against friction, okay, work done against friction is basically equals to against friction is the difference between, this is very important sentence, difference between the loss and gain of energy, gain of energy. What does it mean? That is that if you are going to lose some energy, for example, the gravitational potential energy was lost in the above example. Gravitational potential energy was, let's say, suppose it was, if you remember, let's say it was 320 joules, and this was basically lost, the loss in gravitational potential energy. But if the gain in ke is somehow 280 joules, right? Yani, on this track, if you are going to uh, mean roll a ball and there is a frictional surface, when it reaches to this point, what happens? The gravitational potential energy, does it have, it is 320 joules here, and when it reaches to this point, it is 280 joules. It means how much energy has been lost?
40.
Yes. So that E, yani difference of energy, you can simply write that delta GPE minus delta KE, that is equals to that is equals to work done against friction. That is equals to work done against friction, right? So work done against friction can be calculated again here. So it is 320 joules minus 280 joules, that is equals to, force into displacement. So what was force here? Gravitational force. I want to calculate frictional force, and let's say the distance between this point to this point is suppose 12 meters, right? How much is the distance? 12 meters. So what is the difference? 40. 40 here, and distance is 12 meters, so I can calculate the frictional force. This is basically frictional force. Work done against the friction is 40 joules. If the question is asked till this point, just go ahead till this point. But if there is the work done against friction, then you will say 40 divided by 12, because this distance is 12 meters. This distance is how much? This is 12 meters across this. The body is rolling down. So that means it will be 3 point something. Okay. How much it will be?
3.3.
अस्सलाम वालेकुम। अस्सलाम वालेकुम। आप लोगों को आवाज आ रही है मेरी?
जी सर।
बीच में मैं आई एम रियली सॉरी, आई डिड नॉट रियलाइज, बट मे बी आई लेफ्ट द मीटिंग, आई थिंक सो। यही हुआ था बीच में।
जी जी, लीव हो गई मुझे।
Okay, okay, okay. So where did we leave? What was the last point? You people got it? Yes. Okay, let's move on back. I was telling you that basically this is the 40 joules is the work done against friction, and this is basically the W. Okay, let's start from here. That delta in change in gravitational potential energy and change in kinetic energy appears in the form of work done against friction. And this work done, let's say I have given you an example. Let's say the gravitational potential energy you have 320 joules, and this is 280 joules, and that is F into D. So you will simply say that this F into D is equals to total work done against friction. Yani work done against friction. Okay, got it? Now, moving on, I told you about okay, now what will be the total work done against friction? 40 joules. But again, if you want to find the frictional force, what is that? Friction force is F into D. So D kya hai? D I told you that from this point to this point, it is 12 meters. So you have divided that 40 by 12. So you got 3.3 Newton. That is the work done against friction. So I believe that this will be helpful for you, this all calculation. So right after that, I'm just talking about today's topic. That is the power. So actually power is nothing but the rate of doing work. R. You can write till this point. Rate of work done, or you can simply say that power is actually the energy converted with respect to time, a rate of conversion of energy. And its formula is either power divided by time or energy divided. Sorry, its formula is either work done divided by time, divided by time. Okay? Okay, is it clear?
यस सर।
Okay, so फॉर्मूला याद रखना है आप लोगों ने, where W is work done and E is energy, where W is work done and E is energy, okay, and T is time taken. And one more thing you want to know about this all, that is a scalar quantity, because it is extracted from work, so that is a scalar quantity. So simply speaking, that once you are going to calculate, okay, what will be its unit? Unit will be watt, and watt is defined as 1 watt power will be how much? When you are converting 1 joule of energy in 1 second, or you are producing 1 joule of energy in 1 second, that is your power, 1 watt power. One more formula I would request to recall, that is that power can also be calculated by this formula, that how much faster an object is moving by the application of a force. For example, if you are going to apply a force, if you are going to apply a force on an object, that object is traveling through a distance d in time t. So definitely it has F into V, and you have to recall that where F is the force and V is the velocity, right? So this is just simple concept. Then I will be talking about efficiency. Efficiency is actually efficiency of the system is the ratio of useful. You have to recall this definition, the ratio of useful output energy to the total input energy, right? For example, if I say that I have 660 uh, horsepower or 660 cc car, right? And that 660 cc car is very efficient. So I can simply say that why? Because it takes less fuel, and most of that is converted into the useful output, right? In that way, for example, if I have given you 10 questions to solve, and out of those 10 questions, you people have completely solved 7 questions. You have uh, solved 2 questions a little bit incorrect, and one question is basically unattempted, right? So, what will be the efficiency of you? What will be the efficiency of the student? It means this seven question is basically the useful output of how much total? 10 questions. So I will say 7 divided by 10, that is equals to 70% efficiency. So is it clear to everyone that what is efficiency actually? Efficiency is the ratio of useful output to the total input. So here I have written one more thing, that actually total energy is equal to useful output plus wasted energy, because this all is coming from one source, na? So I can simply say, uh, okay.
Sir, can you say it again? My internet connection is just gone and came back.
Sorry, can you repeat your question, please?
Some connection. Can you
Some
say
connection
the?
problem.
I have connection problem. Can you say the last thing you said?
Oh,
I
yes,
couldn't
yes.
hear.
I said that your efficiency is basically 70%. It means that what is the total given? 10. Out of 10, 7 was useful, plus 3 was wasted. So total is sum of useful wastage. Okay, got it?
Okay.
Okay. So the right after that, this is basically okay, law of conservation of energy. This is basically valid here. It is not that much important for you. This is the important formula. You have to recall this formula, please. This is the most important formula. Most of the questions are asked from your work energy and power, and you have to use this formula for the calculation. That efficiency is the ratio of useful output to the total limit. For example, here is that example. In this example, if I say that I am using 100 joules of the chemical energy or electrical energy in a bulb, out of that, 75 joules are used in light and only 25% is used in heat. This bulb is 75% efficient. But there is another bulb which gives only 10% light and 90 joules or 10 joules light and 90 joules heat. So that is 10% efficient. This is the old bulb. You remember that? Those yellow bulbs, filament lamps, these were getting heated a lot, but their light was not too much. But these are the energy savers. That's why we call them energy saver, because they produce very less energy, right? Sorry, they produce very I mean lot of energy in useful outcome, and they waste very small form of energy or small amount of energy. Okay, okay, is it clear?
Yes, sir.
Yes, sir.
Okay, so that means that this all is basically the game of efficiency. So percentage efficiency is simply nothing but multiply by 100, so you can do it properly. I believe so that it will be helpful for you all. And next, moving towards the next, all this is basically related to efficiency and efficiency calculations. Forget about that, no issue at all. We will practice the questions. The next important thing is the energy resources. Actually, energy resources are resources, that thing which is used to produce the energy. What is a resource? Resource is that thing which is used to produce the energy. So there are two type of energy resources. One of them is renewable, and the second one is basically non-renewable source, right? So I will classify that the energy resources are basically two. One are renewable, and the second one are non-renewable. Okay, renewable and non-renewable. You got the point? Renewable is, as by name, it is very clear. that you can re- replenish them. Replenish mean you can accommodate them more quickly as you are using them. For example, if I consider that I'm using solar energy is basically used at very high rate. But as compared to that, if I consider the coal or the that the energy what I was talking about,
Fossil fuels.
fossil fuel. Yes, sorry. Thank you very much. Fossil fuel. That energy is basically produced after very long time, but we are consuming it at very higher rate. That means that that is a non-renewable source. So sun is the most important source of energy. Only geothermal, this is a past paper question, and nuclear energy is independent of the sun. Rest all energies which are taking place in any form, any other form, chemical, hydro, whatever that is dependent upon sun by all means, or directly or indirectly. So I am just going to describe. That is why I have just selected these notes, because here I had to show you some things. That is why the visuals were important in this. Renewable source of energies, I have uh, been adjusted all of them here. They are basically wind, hydroelectric power station, then biomass, then solar and waves. There are six actually by nature. So maybe I have enlisted them all. Yes, there are six. Yes, solar, hydro, wind energy, thank you, and tidal energy and geothermal and biomass. So these all are basically your renewable source. So the question will be asked to you. You have to identify the renewable source of energy. So is my question clear to you? That you will be asked to identify which source is renewable and which is not. Okay. So how many of you are able to recall them? Six: solar, hydro, wind, tidal, geothermal, and biomass. So they all are basically your renewable. Actually, rest all is very fine. You people now about this solar, that the energy is coming from the sun, hydro, that the energy is coming from the water and we are converting it into electrical energy, wind with the help of windmills, and yeah, these three, the later three, tidal, geothermal, and biomass, they're not common too much. So I will talk about them one by one. Biomass is one of them, which means that some of the organic matter is basically decomposed, like, for example, if I say that we use the waste of the woods and crops and non-industrial, where the no industry there are no industry, any agricultural countries, what do? We basically use those plants to get decomposed, right? And actually gas and ethanol, they are mixed together or they are combined, so we get this biomass. The plants containing sugar or the starch can be made into alcohol. This is ethanol actually, right? It burns into fuel and mixed with the gasoline and it forms gas oil. Mean gasoline and alcohol combination. Okay? So right after that you have geothermal energy. Geothermal energy is basically a sort of energy in which what do we do? Our earth is having a hot crust inside this one. There is magma inside, and that magma causes a huge, you know, heat at this area. So what do we do? Those areas where volcanic eruption is nearby or the mountainous areas, there we drill the water into and we inject the cold water into and we place or we shift it closer to the magma. From here, these are the conventional currents. Hot water moves up and we take it out with the help of a boring machine or the bore. Here I have just explained it in detail. Just did you see that? What did I do? I mean, this was the very important diagram for me. That is why I have just sent you these notes. In this diagram, did you see that we are injecting the cold water into the rocks layer, right? And due to that, this is converted into hot water here, and that hot water is pumped out, right, with the help of the motors and all that stuff. And then this water is basically placed in this, you know, heat exchange chamber. And in this heat exchange chamber, the hot water is further boiled in converted into steam, and then steam is thrusted the turbine, right? The turbines run, and the water loses its energy, and then it is collected back here in this chamber, and then it is shifted down into the injection, or through the injection level into the into the earth. So in this way, the water is not wasted; it is recycled. Did you see the recycling of the water? And our generator turbine is going to run the generator, and electricity is being produced. So this is the best method of producing electricity at the yani those volcanic eruption areas. Okay, so here, what type of energy change takes place? Geothermal is converted into geothermal energy is converted into our geothermal is supplied to the boiler, that is supplied to the turbine. Yani after that turbine comes out, then generator, then electricity. So these all are the blocks. I tried my best to represent it at the best level what I can, but this is basically what the geothermal energy. Okay, then we have another setup that is basically that is basically available in your hydroelectric power. Actually, this is a small setup. If you see, this is a local hydroelectric power plant. You just throw some water on this turbine, and this turbine is connected with a conveyor belt, and then it is connected with the motor. Actually, the shaft of the motor is rotating, and that shaft is converting the mechanical energy into electrical energy, and then this lamp works. And actually this is workable at very large levels, where we have uh, the water stored in the reservoirs, and that stored water is basically supplied the gravitational potential energy of the water. This is the gravitational potential energy of the water. It is converted into kinetic energy. It runs the turbine, and turbine runs the generator, and then electricity is being produced. And then water is not utilized. It is just recycled. It is coming on the lower deck, and then by either clouds or by artificial we convert that, or we shift that water back to the higher level. So here in this chamber, what is basically all gravitational potential energy of the water. These are the exam questions what I have placed here. Water at the higher level consists of potential energy. That energy is converted into kinetic energy of the water, and that energy is basically converted into mechanical energy of the running turbine, and then it is converted into electrical energy. Is it clear? And then electrical energy is provided to the consumers, right? Then we have the tidal energy. Tidal energy is basically that type of energy which is used by the tidal barges. Actually, this is nothing. Do you remember, in the oceans there are high tides and low tides? During high tides, the water is stored in the dam tide, and during low tide it comes down, and during that it basically it operates, it has it transfers the electrical and mechanical energy, and that mechanical energy is converted into electrical energy. So this is the entire slide. I believe that you people will be able to read it out, as I have sent you these notes. So there is nothing more difficult in this one. So I will be moving to the next, that is the solar energy. Solar energy में क्या होता है? Solar energy is basically the energy from the sun mostly, and that is converted into electricity by using solar cells or solar panels. Actually, it is consisting of light, infrared, and other radiations. So once we are going to convert those lot of radiations or lot of range of radiations, basically those radiations are into two forms. One, we are having solar cookers or solar geysers. Like directly they use infrared. And the second, it is basically with the help of these solar panels, we convert solar energy into electricity. But there is another one, this one. It is not the s- that solar mirror. Sorry, it is not the solar panel. It is basically the solar mirrors. What do they do? They reflect the energy, and within this is the internal structure, and this internal structure is very important. Basically, the what energy is, you know, this all energy is yani the sun rays or radiations in the form of infrared, they fall on it. What do? They basically uh, convert, yani the cold water is coming out and that cold water is heated through these ducts. It is converted up और वापस ये किस में आ जाता है, in this chamber, and from here you are using the hot water and cold water. So these are called solar geysers as well, right? Then we have wind energy. Wind energy is basically that type of energy which is used uh, in the very large wind farms where windmills are being used to produce energy. So there are so many areas where you people can have this advantages and disadvantages. So please, I will request you all. These all are the readable files. You have to read them all. And if you find anything problematic, please ask me. I will be there to help you out because I have told you plus and minuses of all these in short. So this will be actually the complete game of your energies and energy resources. Why I just made this last slide, yani these last few slides so fast, because that all is theoretical and you people can go through these notes, and if you find anything problematic, if you consider that okay, I have to, yeah, this was the bar. Oh yes, this is basically the solar bar as a tidal bar, so that produces the electricity. And then I have, yes, I have added all the visuals for you for different uh, changes, electricity. This is basically the thermal geyser, and then this is the nuclear. In nuclear, you have to consider one thing. This is very important. That actually, in nuclear energy, what happens? The red, the energy is coming from the nuclear reactions. When the energy is coming out from the nuclear reaction, actually that energy is converted into heat, and then that heat is used in the reactors. So I will say that the nuclear fission is taking place in stars and sun, right? And that causes the nuclear, yani thermal energy of the world. Entire thermal energy is coming from fusion, right? This is basically coming in case of thermal energy. And once you are going to have the reactors, in reactors, what do you do? In reactors, you have nuclear. Sorry. This is fusion. Sorry, my bad. Fusion. And in reactors, there is fission reactions. Fusions are basically that splitting of the nucleus into small one. You just recall this line because this is the entire topic which will be asked to you in your nuclear topic. So splitting of heavy nuclear into small, heavy nucleus into small, right? This is basically fusion, and fusion is small into heavy. They are two opposite things. Okay, so we will be talking about these all inshallah in detail, and hopefully this all will be helpful for you. There are not uh, any big details of required details required from this topic. That is why I have saved these 7 8 minutes for you just to uh, make you go through in the worksheets. Okay, so just give me a second. Just opening up the worksheet for your work energy and power, and I will tell you how these are, what type of questions do we have from this topic, work energy and power. Okay, first of all, let's say, let's talk about this one. These are two files what I wanted to open up. Okay, let's open this one first. Let me share this screen with you or share these files with you also. Okay, let's open it up. Okay, these type of questions are asked to you, right? For example, this is your figure 3.1 that shows a model of a wind turbine. Oh, sorry, I have to open this with notes. Now it is editable. Now is it visible to everyone? Okay,
Visible.
3.1 shows a model of wind turbine. Okay, and that model is basically uh, used to demonstrate to use the generated energy generating electricity. The wind is blowing towards the model as shown, right? Wind is blowing to the model. It is the turbine blades. Wind is blowing. Now, the mass of the air passing through the circular area swept out by the turbine blades each second is 7.5 kg. The kinetic energy of the air that passes through the circular area each second is 240 joules. Are you getting the point? This is the information in this question. This is a real time question, past paper question. And it is asked calculate the speed of the air. What to calculate? Speed of the air. Right. So, how to use that formula? Yani, you know, I have to figure out the kinetic energy because the kinetic energy of the air is given to me. So, which formula will I use, Muhammad? Muhammad, are you there?
Um,
What is the formula for kinetic energy? Ibrahim.
Sir, I actually forgot.
Oh my God. You have to recall, man. 1 upon 2 m v square. अरे भाई ये फॉर्मूला सही है? Hello, Ariba. Are you in the class? Right.
यस सर।
बेटा जी आप लोग सारे क्लास में हो, ऐसे ही है?
जी सर। जी
ओके
सर।
गुड। तो क्या ये फॉर्मूला सही लिखा है मैंने? इज इट करेक्ट फॉर्मूला और नॉट? इब्राहिम.
ठीक है।
Yes,
Okay,
sir.
so I can calculate velocity from here that this will be 2 times kinetic energy divided by mass of the body, right? Mass of the air entering. So what is the kinetic energy? 2
But
into 240 divided by what is the mass? That is 7.5. So can you please calculate this for me?
सर 64।
3 364?
नो सर 64।
Oh my God, 364 तो बहुत ज्यादा था इसलिए मैं तो डर गया. 64 meters per second is the speed of here. Your marks allocation is 1 mark for this all, 1 mark for the placement of the values, and 1 mark is to write the answer
सर
64
रूट
meter per second along with the unit.
वो अंडर
Oh,
रूट में अंडर रूट।
इसका स्क्वायर रूट भी लेना है?
जी
Oh,
सर।
okay, okay. Sorry,
8
sorry,
आर।
sorry. Oh, so I thought that you have calculated. It is v square. Right now, It is V square. So you had calculated that all. It is square root of 64 is equals to 8 meters per
8.
second. So the answer will be 8 meters per second. Okay, is it clear to everyone? The kinetic energy of the air drives a generator. Now, this is actually the windmill question. That is why I have just gone through all those areas. Generator state the input power of the air passing through the turbine blades. State, no need of calculation. So, here it was mentioned that the kinetic energy of the air passes through the circular blade is 240 joules in a second. So, if I define power, what was power? Power is energy divided by time. So that energy is basically kinetic energy divided by time. So what is kinetic energy? 240 divided by 1 second. So that gives you an idea that yes, it is 240 joules per second. It is actually 240 watt. Is it clear to everyone?
Yes, sir.
Clear? Okay. Ji. Next part of this question. Uh, okay. You will not be able to solve this one, these type of questions, because here there is one interesting thing in this discussion, that electric energy has a formula. Okay, if I tell you that formula, you people can do this all questions. Just recall one thing. Just recall one thing, that the formula of electric power and electric energy. Okay, electric energy is basically equals to VIT, and electrical power is equals to VI. Okay? Electrical power is VI. Okay? So you can use this formula where V is potential difference, yani voltages. Right? Just recall it, because I will talk about this in detail in electricity topic. So it is potential difference, right? Are voltages, and this is basically your I is your current.
Correct.
You got it. Now moving on, this is actually a situation where it is said that the output current of the generator is 2 ampere, and the potential difference are the voltages of the generator are 11 volt. Calculate the output power of the generator. So I have to use the formula, as I told you, that output power is equals to V into I. You can simply recall it VIP. VI equals to P, so VIP. That's it. That's what it is, and I have finalized it. Okay, done. So क्या होएगा आपके पास? It is 11 into 2.0, so it is 22.0 watt. Everyone agreed or not? Hmm?
Yes, sir.
Okay. Now calculate the efficiency of the wind turbine. So for efficiency, what is formula?
Efficiency is equal to output, total output.
Useful
One
energy
input.
Yes,
output over
useful
total
output
energy output.
divided by total input. So efficiency is useful output, OP stands for output, divided by total input, IP stands for input, into 100. Actually, this is in terms of your power, so I will write all the values of the power. So useful output power is this one, 222.0 watt. And what is the total input? 240 watt into 100, because that all is given to you na, in this situation, in this question, because this was the input energy, 240 watt. This is the output energy. So you will calculate these all and you will get the answer. What is the answer?
9.1.
22 by 2. Huh?
9.17.
9.17 means 9.2%. Is it?
Yes.
Okay. Now, this is actually your previous knowledge which was asked to you. The density of the air is given to you. calculate the volume of the air passing through the circular area struck by the blade in each second. So, you know, what is the density? Density is equals to
Mass of
mass upon volume, and here volume will be equal to mass divided by density. So mass is how much? Mass is, we have calculated the mass. Sorry, it was 7.5 kg. 7.5 kg. And what about the density? Density is 1.3. So can you please calculate this for me in a second?
5.6.
5.6
5.6 cubic.
76.
Yeah, 5.76 means 76. So it is 5.8 cubic meter. Okay. Okay, ji?
okay, sir.
Okay,
So
sir.
these type of questions are asked to you. I'm gonna share this file to you, and I hope that this will uh, you people will be able to solve all these questions, inshallah, before you got appear in your paper, yani in the quiz. Okay. Oh, sorry, sorry. Wrong number. I will send it to you also later on. Okay. Okay, ji. See you then.
Love.
Allah Hafiz,
Allah
sir.
Hafiz. Allah Hafiz.